Okay, in real world applications, number 2 example works with maximizing area. And in this problem, Mr. Maynard wants to put together a small garden behind the garage. The space that they have allotted right now is 125 feet long and 25 feet wide. How can they maximize the amount of area that you would have to plant a garden? Again, this equation is now provided by a intercept form that is given as a of x equals 125 minus x times the quantity 25 plus x. In order to find the equation for these, I am literally going to only give you 2 values in the equation. Okay, in the story problem, I'm going to give you one big number and one smaller number. That larger number will always be that number minus x, and the smaller number will always be that number plus x in sets of parentheses. Okay, the approach to these ones are slightly different than the previous one. On this one, we are going to start by finding the x-intercepts. And to do that, I'm going to take each of these expressions and I'm going to set them equal to 0. So my x-intercepts I'm going to take 125 minus x equals 0. And I'm going to solve that. Again, you can choose to solve this any way you want. We can move the 125 to the right-hand side. I can move the negative x to the other side. You choose which one works best for you. My suggestion here, because it's minus x, and instead of trying to move the 125 and then losing the negative on the x value, I'm going to go ahead and add x to both sides. So I'm going to put plus x, and that's going to give me 125 equals x, which gives me an ordered pair of 125, comma 0. And I'm going to do the same for the other one here. I'm going to take 25 now plus x, and that equals 0. Here, since I have a positive on the x, I'm going to move the 25, and I'm just going to subtract 25 from both sides. This is then x equals negative 25. Or it gives me an order pair of negative 25, comma 0. Okay. Later on, as with number 1, we have to describe what the x-intercepts mean, what the h of t or the a of x here intercept means, and what the maxima means. So we might as well go ahead and do that now. So the ordered pair 125, comma 0 will tell you that we have no length which equals no area. Okay, again, as previously stated, what the 125 here tells me, or whatever my value here tells me, is how much I'm removing from my width or my length. Okay, so if I take 125 and I subtract all of that 125, I don't have any length left. I have one straight line that goes straight down. Likewise with this one, negative 25, comma 0 means that now I'm not taking away from the length. I'm actually taking away from the width, which means I've taken all 25 feet that I did have and I've removed it and added it onto the length, which means now I have no width. Which again tells me that I have no area. Moving to the other side of the board, I'm going to work out the axis of symmetry. So here again, it's a little bit different approach here. So the axis of symmetry, or the AOS, I'm going to find by taking the average of those 2 values that we just found. So I have x equals the 125, I'm going to add the negative 25, and I'm going to divide it by 2. Again, it's finding the average. So x equals, this would be 100 over 2, or x equals 50. With those two items now, I can actually use these to find my X scale. And in using my X scale, then I can create my table so that I can kind of narrow down the possibility of numbers that I'm going to use. In number one, I went by ones. I started with 0 and I went by ones. If I do that, I could end up going for a very long time, because again, here I have this x-intercept now, and I'm only going to really be concerned about the positive one. So if I go by ones, this tells me that I'm going to have to go all the way up from 0 to 125 before I get a 0 back in return. So we don't want to do that. We want to avoid doing as many of those things as possible. So here, we're going to take that positive x-intercept, and to find my scale, you take the positive x-intercept, and you divide it again by 6, because I have those nice landmarks here that I mentioned in number 1. So if I take 125 and I divide that by 6, that's going to give me 20.83 repeating. Okay. The nice thing here again is that I'm allowed to round this off. You can round it up. You can never round down. You have to round up, otherwise you're not going to be able to cover enough mass. So here I could round up to 21, or to go with the nicer flow of things, since we have 50 for my axis of symmetry and 125 for my x-intercept, I would say go ahead and round to 25 so that we have some nice landmarks. Okay, so here I have 0, and if I round it to 25, I have 25 here. This would then be 50. This would be 75. This would be 100. This would be 125. And then the end here would be 150. Okay, from this point then, again, as I mentioned, we're going to find the table. So I'm going to create my table here. Try to give myself as much space as I can. This is X over here on the left-hand side. This is going to be my equation here in the middle. Okay, similar to the previous one, I'm going to do these as an H table so that I can see all of the work that I need to see. Okay, at some point you may not need to do all this. You may be able to have a calculator that will find all the work for you. But up until that point, I want to see this all written out so that I know that you understand where these numbers are coming from. Okay, so this is going to be x comma a of x. Again, my input comma my output. Again, I'm going to start with 0 on all of these in the top left corner here. And then with this one, since I've already found my scale, what I'm going to end up doing is I'm going to use the scale that I have here. And those are going to be the numbers that I have in my table. So from 0, I go to 25. From 25, I go to 50. Again, I have to make sure that I include my axis of symmetry. But again, because now that the axis of symmetry is 50, that's one of my numbers in the table. Okay, if it was, let's say, 45, then I would have to put 25 and then 45 followed by 50. Okay, so make sure you include it. After 50 now, because again, the scale, I have 75. From 75, I have 100. From 100, I have 125. And I'm going to stop at 125 because, again, that's my intercept here. I'm going to go and plug in until I know that I have an output value of 0 or a negative value. And here I've already shown that I have an output value of 0. So that ordered pair can be written right away. 125, comma 0. I don't have to show the work here because I've already got work here. Okay, so we go back to the beginning, plug in 0, we have 125 minus 0 times the quantity 25 plus 0. Make sure that your x values here and here are the same value every time as you work across. Okay, that's a very common mistake that I see a lot of times. So we have 0, comma 3,125. If I plug in 25, 125 minus 25 times 25 plus 25 is going to give me 25 comma 5,000. When I plug in 50, again, this is my axis of symmetry. Okay, so I'm going to note that next to this. This is my AOS. I have 125 minus 50 times 25 plus 50. And that's going to give me the ordered pair 50 comma 5,625. Continue, I have 125 minus 75 times 25 plus 75. Work that out, you have 75 comma 5,000. And if you plug in 100, we have 125 minus 100 times 25 plus 100. Which is going to give me the order pair 100 comma 3,125. Okay, now that I've got that, move this thing out of the way, I'm going to find my scale here, my A of X scale. And in order to do that, again, I'm going to go back to that point where I plugged in my axis of symmetry. I need to find the largest Y value that I have in this table, and that's going to come from your axis of symmetry every time. Okay, so I'm going to take this 5,625, and I'm going to divide it again by 4 because I have those nice 4 landmarks. So my A of X scale is the 5,625 divided by 4, which gives me 1,406.25. Again, this is a bad decimal, so I'm not really going to work with that decimal. I'm going to have the ability to fluctuate this a little bit. The question is how much? Can you go to 1,407? Sure, absolutely, if you want to make your life miserable. Okay, these problems are going to take long enough. Instead of trying to rack your brain and trying to hurt your brain that much, let's take this, and since it's in the thousands, let's round it up to the nearest 100. Okay, and again, you have to round up. You cannot round down. So if we round up, I have 1,500 as my scale. Okay, so each line here is 1,500. Here I add another 1,500, that gives me 3,000. Add another 1,500, that gives me 4,500. And add another 1,000 at the very top here, that's 6,000. Okay, and again, to help with further ability to graph accurately here, I want to find out what each little mark going up stands for. So I'm going to take this number again at the bottom here, whatever my scale was here, and I'm going to divide it by 5. And that gives me whatever each line is. So if I take 1,500 divided by 5, that gives me 300. Okay, again, for some of you, my recommendation would be to graph and to draw and write out what every single one of these lines represents. So write 300, 600, 900, 1,200, 1,500, all the way up to the 6,000. Okay, if you don't need to, again, be your own advocate. If you need to do it, do it. If you don't need to do it, then don't worry about it. Okay, so once we have these points, then I'm going to start graphing everything that I can. I have 0, 3,125. I have 0. I go up to 3,000. I have 3,300 if I go to the very next line. So we're not even quite halfway. So make a dot here. Again, I'm not going to go through this in a fine microscopic little fine-tooth comb, because each step again now ranges from 0 to 300. Okay, That's a little bitty space, especially when you get the graph on the paper that I hand you for the worksheet. That's a small amount of space to work with, and you're gonna have to just do it as best as you can, okay? Going to this next point, we got 25, 5,000. We have 25, we go up to 4,500. This would be 4,800, 5,100, so I'm just below that mark. Then we go up to that AOS value again. That's my vertex now, 50, 5,625. I go over to 50. I go up, I have 4,500, 4,800, 5,100, 5,400, 5,700. So I'm just below that point. Okay. On to the next one, we have 75, 5,000. The nice thing is that reflects off of the 5,000 from the 25, so I can just go here and go straight across on the 75 and make my dot. 100 was 3,125. Similar fashion with this 0, 3,125. I can just line it up here. And then nicely here, I have the 125, 0. So I'm actually right on the axis here. Okay, and we can nicely, smoothly draft this line. We start this dot, and we just go around. And again, it should be a nice, smooth curve. Okay. And then again, I'm gonna go back and identify things. I'm gonna again go through, and I'm gonna plot the axis of symmetry as a dashed line. So it's at 50. So here at 50, I'm gonna do this dashed line. This is my AOS, x equals 50. Okay, and we have the three things then to identify. The x-intercepts, which we've already done. Okay, the x-intercepts are over there, already listed what they are, as well as what they stand for. So we don't have to go back and do that again. Okay. The next thing we have to do then is the A of X intercept. The A of X intercept is this ordered pair right here. Okay, and again, as previously stated, this ordered pair comes straight from the very first ordered pair of the table. So we have 0, 3,125. And what does that tell me? What that tells me here is that if I do not move the length or the width at all, if I move 0 spaces in feet, I have the initial area of 3,125 squared feet. Remember again, this is area, so this is a square feet measurement. The third and final thing that you have to find here is the maxima. And the maxima again comes from the very intercept or the axis of symmetry point or the vertex. And again, it's just the y value of that ordered pair. So this is the maxima. And that tells me that I have the ability to have up of 5,625 square feet is the max area possible if we shift the length 50 feet, because that's the ordered pair, 50, 5,625. If we shift 50 feet, from the length to the width, and that would make it a square in shape. That would be 75 feet by 75 feet, and that would give me the largest amount of area possible for my garden. Again, I know that's a lot of information to process. Again, take your time, do it right, send me pictures of things if you need to, and get them checked, and then ask questions if you have them.